All right, example 4, expand. The word expand does not mean to make things bigger. It means to get rid of the parentheses. All right? And what I've got here is a algebraic term, 4x to the negative second over y to the fourth, being multiplied by a quantity of an algebraic expression minus a second algebraic expression. And the first thing I want to do in this problem, and if you do this step, it makes the problem about 20 times easier, is fix each of those circled objects so they're all simple, just like we did the last 3 problems. Make them all as simple as possible. I don't want negative powers. I don't want to have multiple x's or y's or z's. I just want one of everything. So, 4 is fine. Y to the fourth is fine. What's wrong with x?
It cancels out.
It doesn't cancel out.
Goes to the bottom.
It goes to the bottom. I'm not dealing with this stuff yet. I'm just dealing with this one thing here. All right. So if you're starting to multiply right now, stop multiplying and pay attention to what I just said. What I just said was this. Before we start multiplying, we want to fix every term in the problem to make it the simplest problem possible. So that red circle thing, the x to the second power belongs in the bottom because it's negative power. We put it where it belongs. Then I put my parentheses.
Wait, what about y to the fourth?
Yeah.
Why is it on bottom?
On the
Y to the fourth on the bottom. It's positive power. All right. So 4 is 4 to the...
just the red circle.
Yeah, I'm just dealing with the red circle. I'm not dealing with the blue or the green yet. I'm just dealing with the red. Again, deal with each term individually first before you distribute. All right. So 4 is to the positive first power. It's right where it belongs. Y is to the positive fourth power. Right where it belongs. X is to the negative second power. It belongs on the bottom. Put everything where it belongs. What's wrong with the green circle term?
Nothing.
Absolutely nothing. I am going to write it like this though. Y to the fourth x squared over 1.
All right.
If I have a fraction in a problem, it makes sense that everything's a fraction. That gets me thinking fractionally, so nothing weird happens. The minus is officially part of this last term, and that minus is not a negative power, it's just a minus sign. All right? This 3 is to the first power, x is to the fourth, y is to the negative second. What's messed up about that?
The y should be on top.
Y is on top. So 3 is perfectly fine where it's at, x to the fourth is perfectly fine where it's at, y squared belongs on top. And again, everything moved upstairs, right? So I'm going to put over 1 to create a fraction look to it. That is priority 1 in these problems. Do that first, problem becomes simpler. Step 2. I'm going to multiply this times this, and I'm going to multiply this times this. The distributive property is going to happen to expand to create this expansion they're asking us to do. Now, this is where I want you to be patient because I know that some of you are going to see things cancel out, which is great. Okay, cancel out in the next step. All right. What I want you to do in this step is I want you to multiply. I don't care about things. There's the same thing on top and bottom. Let's start crossing things off. Don't do that. Simply multiply what you have. So, if I'm doing the red times the green, and I just look at the top times the top, I got a 4, a y, and an x, right? They're all different. So all I can do is stick those together. 4x squared y to the fourth. I personally like alphabetical order, so I'm going to do that. It doesn't have to be. If you put 4y to the fourth x squared, you're perfectly right also. On the bottom, if I do x squared y to the fourth times 1, I get x squared y to the fourth. And I can see just as well as the rest of you that things cancel. Save it. All right? Moving on. 4 times negative 3 is a negative 12. Okay, here's another thing that happens to some people sometimes in these problems. You multiply x's, you add powers. You multiply numbers, you add numbers. Okay? I'm multiplying numbers, I multiply numbers. If I multiply letters, x times x, if it should happen, it doesn't. But if x times x happen, I add the powers, right? So, 4 times 3 is equal to 12, not 7. Be careful that we're multiplying. I've got x's and y's that don't change. X to the fourth, y squared. On the bottom, x squared y to the fourth times 1 is x squared y to the fourth. Get the product you get just by simply multiplying the fractions. Top times top, bottom times bottom. Then, fix each fraction individually. Looking at canceling things if possible. X squared is exactly the same as x squared, they cancel. Y to the fourth same as y to the fourth cancels. If everything cancels, you get 1, and you have to write it. I got a 4 left over, which is perfectly fine. 4 is what's left over from the first term. Second object, I got minus 12 obviously, right? I've got too many x's, I've got too many y's. 12 is perfectly fine, there's nothing wrong with the 12, so I'm not messing with it, I'm leaving it right where it's at. Where does x belong?
On the top.
On the top because 4 is bigger than 2. And we subtract 4 minus 2 is 2. Where does y belong?
Bottom.
Bottom. And 4 minus 2 is? 2. Okay. So when you're reducing these fractions, it's just like the last 3 examples. You have the same letter happening on top and bottom. The higher power determines where it belongs. Big power minus small power determines what its new power is. This is what the final answer to the problem should be. That is the technique I'd recommend for now. As you master the technique and get better at it, find shortcuts, find places you can cut corners on. That's great. You start cutting corners, keep getting the right answer, great. You start cutting corners, getting the wrong answer, go back to this process. This is the whole thing. Not cutting any corners whatsoever. But again, if you find ways to cut corners and still get the right answer, you understand how to do it, perfectly fine with that. My goal for every one of you is that you're as fast as I am at math by the time you graduate. That's what my goal is. I hope that happens. I hope it happens because you get a lot smarter, not because I get a lot dumber. Okay? I'm really, really fast.
Yeah.
All right? Okay? And I'm really, really fast because I paid attention to detail when my teachers told me to do stuff. All right? So hopefully I don't forget everything I ever learned, and that's why you got as fast as I did. Rather, you learn everything I know, and that's why you got as fast as I did. That's what my goal is for everybody. So please, pay attention to detail, and again, cut corners at your own ability level. And if you can't cut corners and get the right answer, go back to going the whole way through. All right?